Again, welcome to Java Programming 2. In these lectures, we will go through the concept of inheritance in object-oriented programming. In our previous lectures, we discussed about what is an object-oriented programming and also design. And we talk about the main three features, which is the inheritance, polymorphism, and encapsulation. So encapsulation is about safety. Polymorphism is about having one thing to do many things. Inheritance means about reusing the code. So here, our main objective is to learn about inheritance. We may go more details today how to implement it. In the process, we are going to learn some few terminology here. For example, what is a subclasses and also what is a superclasses. And also a superclass. In some textbooks, we may use the term base class or the parent class. A subclass can be the child class or the derived class. We may discuss the difference between the two. But for example, if we have a program and we have two classes, let's say we have a person class and also we have an employee class. We again define both classes. Now, for example, we know that a person can have a last name and a first name. Also, an employee can have a last name and a first name. We don't want to declare the same data and methods for both classes. It's like we are writing a redundant code. So we can bring the concept of inheritance whereby I may have the person class as the superclass or the base class. And I may have the last name and first name and some method already declared there. Now, when I declare my second class, which is the employee class, employee also have a first name, last name, but I'm not going to declare it. What I'm going to do, I will let employee class inherit everything from the superclass, which is the person class. So that's the whole concept of inheritance. So inheritance is kind of like reusing our code, reusing the code, or redundancy, removing redundancy code. So we're also going to explore how to override the methods of a superclass. The concept of overriding method is that I can have one method. Let's say the method is to calculate salary. It takes two arguments, which is the number of hours work and the rate. Now, I have this class in a superclass. I may have the same class in subclass, the same parameter, the same data type, the same name. That is overriding. Now, overloading means I may have the class with that method. Let's say the parameter will be integers or two parameters. And I may have the same method in a different class or a different method. This time, in a different class, the same method name, but the parameter, maybe the data type will change or the number of parameters will change. Normally, it's very common to overload constructors. I may have a constructor that I may build an object using only two parameters, or I may build an object using three parameters or any amount of parameters. Let's say the two parameters, the third will be a default value. But the third constructor, all the three parameters or the data may be different values, no default values. So we're also going to examine how constructors of a superclass and subclass work. So normally we have a keyword called super. Now, if I have the employee class and I have the person class, now when I'm going to create an object for employee, we should know that the employee inherits the last name and first name from person class. So I need to call the superclass, which is the person class constructor, inside the subclass, which is the employee class constructor. So that's when we have to use the keyword super, and again, we shall go through that. So first, we start with the definition, inheritance. Inheritance definition is that we have a relationship called ise. So for example, employee is a person, an object is a circle. So I may have an object class and a circle class. Object may be my base class or the super class, and a circle will be my subclass. So inheritance relationship type is called the ise relationship. We also have a single inheritance, which means the subclass can only inherit from one single superclass or the base class, which is supported by Java. We also have a multiple inheritance. A multiple inheritance means the subclass can inherit items from more than one superclass. Again, Java does not support it. An example would be a C++ language support multiple inheritance. So in Java, a class can only extend the definition of only one class. So we have in Java, we use single inheritance. So this is an example of inheritance. Let's say we have a superclass named shape. We have a class named circle, but the class named circle will be our parent class or a subclass. Is going to inherit everything from shape. And the same thing with a square. Square can inherit everything from rectangle, and rectangle can inherit everything from a shape. Now, when we have two classes, let's say the circle and a shape, if I'm going to declare it, we use the keyword extend. So I may have class circle extend shape. Extend shape means, again, circle is going to inherit everything from shape. So this is the syntax for declaring a class within inheritance concept. So we have the modifiers. The modifiers can be either private, public, protected. The keyword class and the class name. Then the keyword extends. Then the existing class name. Existing class name again is the superclass. Is the superclass. Then we may have any member list that's including the data members and other methods. So this is an example here. We have a public class, circle, extends, shape. Again, this means a circle is the subclass and is going to inherit everything from a class named shape. This class is public. So public, the keyword class, circle, extend, shape. Then within the curly braces, we may have our data members and the methods, including the constructors, etc. So now let's go through the inheritance rules, which is very important. So first rule said that if we have a private member for a superclass, then it's only private for the superclass. As we all know, a private member, that means any other classes or any other method from different classes cannot directly access the private member of another class. So private members of a superclass are private to the superclass, which means other classes or other methods in different classes cannot directly access the private members of the superclass. Also, we said that a subclass can directly access the public members of the superclass. So which means if the superclass members are public, any other class can directly access it. Now the concept will come to the keyword we said protected. If the superclass members are protected, it means only the classes that inherit the superclass can directly access it. But the public members, again, any class outside can access it. Now, The subclass can also include additional data and or method members. We will see an example of this. An example also was the employee. We know employee class was the subclass. The person was the superclass. Person have only two data members, which is first name and last name. Now, employee also can have three or more. First name, last name, hourly rate, number of hours work. So we have 4. So that's why here we are saying that the subclass can include additional data and all method members. Also, we said that the subclass can override. Override means we are redefining the public methods of the superclass. So example, we may have a method, a public method in the person class, which is a superclass, to calculate salary. Then we may have the same method in a subclass employee to calculate salary also. But they may work in 2 different ways, but it's the same parameters, the same name, everything is the same. In this case, we are overriding the method. So here we say, however, this redefinition applies only to the objects of the subclass, not to the object of superclass. So if I override a method of a superclass, I can only use that method in the subclass. So I can create an object using the subclass, then I can use that method on that very object for the subclass. Also, we said that all data members of the superclass are also data members of the subclass, since we already said that when the subclass inherits everything from superclass, it can use everything that the superclass have. The only thing, if the items are private, it cannot directly access it. The subclass cannot directly access it. So here we also say that similarly, the methods of the superclass, unless overriding, are also the methods of the subclass. Now, when you override a method of a superclass in a subclass, you can only use it for subclass. Also, here they say we should remember rule 1 when accessing a member of a superclass in a subclass. Rule number 1 said, if all the data members or the members are private, then we cannot directly access them. So if they are private, then they are private for superclass. Now, to write a method definition of a subclass, we need to specify a call to a public method of the superclass. So for example, if a subclass override public method of a superclass, we need to specify call to the public method of the superclass. So in this case, we have to use the keyword super. So here, super dot method name and the parameter list. This refers to us that, again, we are calling using the superclass method. Now, if a subclass does not override the public method of the superclass, we can specify a call to a public method of the superclass. In this case, it's public, it's not overriding. So we don't need to use the keyword super. We just call the method name and the parameter list. So example here is given, we have a class name rectangle. Rectangle have 2 data members, the length and the width. Their data type is double. And the minus here means they are private. Again, this is the UML class diagram. UML class diagram always have 3 rows. The first row will be the name of the class. The second row will be the data members of the class. And the third row will be the methods of the class. As we all know, a class consists of 2 items. The characteristics, which is the data members, and also the behavior, which will be the methods of the class. So here we have the first method here is our constructor. Why is it constructor? Because the name of the method is the same as the class name. And also it doesn't have no returning type, and also it doesn't have no void. So it's a constructor. Constructor without a parameter means it's a default constructor. So we have two constructors here. We have a constructor with a parameter. Then we have a method to set the dimension. Here the dimension will be only 2, length by the width. So dimension takes 2 arguments, the length and the width. Then we have get the length. It will return the length type is double. Get the width, it will return a double because the width also type is double. Then we have a method to find the area of the rectangle. We also can find the parameter of the rectangle. And also we have the special method to string to print our, return the item to be printed as a string. So that's our rectangle class, and it's a base class, or it's the super class. The super class, same as base class. Now we have the boss class, which will be our subclass, or we use the term derived class. Now you can see that here the boss class have only one parameter, but technically it's going to have 3. If the boss is going to inherit everything from the rectangle have 2 data members, so it will include the height. We have 3. Then we also have the boss constructor, 2 constructors, one without a parameter, which is our default constructor. And also you can see that the constructor with parameters, we have 3, because we are going to inherit the 2 data members from the rectangle class. Then we also have a method to set the dimension. You can see that setting dimension, we also have 3 parameters, or 3, because we have height here, and in the rectangle class, we have the height, the width also, and the length. So we have the width, length, and we have the height here. So here we can get the height. Now we don't need to say get the length and the width, because we have those 2 methods already in the rectangle class. And also we have those 2 data members already. So this is the whole concept of inheritance. We are more or less like reusing the code. Instead of having my box here, declare 3 variables, the height is already here. We have the width and the length. We don't need to, because width and the length is in the rectangle class, and we are going to inherit it. Now, instead of using get length and get width, we don't need to, because we are going to inherit it from the rectangle class. So we also have a method to find the area. So we can see that the area method here will be overriding. We have the same parameter and the name is the same. So we can see that the method is the same, but to find the area of a box, we need 3 variables. We need a length, we need a height, we need a width. But if I want to find the area of a rectangle, I only need the length and the width. So this is the whole concept of overriding the method. The method name and the data type, returning, and the parameter, the number of parameters, everything is the same, but they are doing 2 different things. The formula to find the area of a box is different from the formula to find the area of a rectangle. Then we also find the volume. Then we have our toString method. So we can see the diagram here. With this tell us that boss is going to inherit everything from rectangle class. Now we start to implement the code. So first we're supposed to start with the heading of the class, which will be public class boss extend rectangle. The first method is toString. So here we are going to print the height. Then we're also going to print the length and the width. So that's why we are using again the keyword super. This we'll call toString method of the super class. So here, super.toString will print the length and the width. Then I'll print the height. The height again is in the class box, so I don't need any super. Height belongs to the class box. Same thing applies to the set dimension. So when I'm going to set dimension, I need the length, width, and the height. Remember, the length and the width also is in the superclass rectangle. So we use the keyword super.setDimension. Remember, set dimension is a method that is inside the class rectangle also. So it's like overriding. We have the same set dimension. Actually, this will be overloading because the set dimension, it has two parameters for rectangle superclass, which is the rectangle class. But with the boss, you have three. We have the set dimension 1, 2, 3, including the height. So this is called overloading. So here again, we set the height. We said that if the height is greater than or equal to 0, then we should print it. Height is supposed to be a positive value. Else, we are going to set the height to 0. Height can never be a negative value. Then we have the formula to find the area, the method, 2 times the length times the width. So you can see that instead of writing length times width, we are calling the get length and get width method from the superclass rectangle. Plus get length again times height. Here we don't need to say get height because the height is a data member of the boss class. Then plus get width times the height also. So that again will be the formula to find the area of the box. Now, defining constructors of the subclass, as we said earlier, we need to use the keyword super. Now, if I have the constructor for the boss, when you go to the boss class, we have only height. So it's going to initialize only height. But since boss also is inherit from rectangle, which we have the length and width, we use the keyword super method. This constructor is a default constructor. There's no argument or parameter. So the super also the same. Now the second constructor, we have 3 parameters. Remember, super will give us length and the width. So we have super, the length and the width. The height belongs to the boss class, so we just assign h to the height. So these are the 2 constructors for the derived class or the subclass. We have the boss constructor, default with no parameters, then boss constructor with parameters. So we have a diagram here. For example, we want to create an object. So when we create a rectangle object, name my rectangle using the new keyword. New keyword, as we said in previous lectures, it will dynamically allocate a memory space for the object my rectangle, and it will assign 5 by 3, the length by the width. Now we create a new object named my box. This time we are using the class box. Remember, the box class have 3 parameters. So the constructor here have the length and the width and also the height. So this will be the diagram. Our box have the length, width, and the height. Rectangle have only the length and the width. So this is the whole. This will happen in the main method. So in the main method, we are going to declare or create our objects. So here we say that a call to a constructor of a superclass is specified in the definition of a constructor of the subclass. So when a subclass constructor executes, first, a constructor of the superclass executes to initialize the data members inherited from the superclass. So that's why we can see the boss constructor. First, we use the super method. So starting with the super first means I'm going to get the data members of the super class, the length and the width. Then we'll return the height also. And here we say first the constructor of the class rectangle execute to initialize the instant variable, the length and the width, which is the super. And then the constructor of the class boss execute initialize the instant variable height. Now when we go back again, we can see that the boss have only height as its data members. Rectangle have length and the width. So when we call the constructor for the boss, we need to use the super to get the length and the width. Then the double we don't need because the double is already in the boss class. And that's what we did here. So we have the default constructor boss. We call default super to give us the default value for the length and the width of the rectangle class, which is the super class. Then we initialize our height. Now, a constructor with parameters, we have the L and W, which is the length and the width. We initialize it with the super again. Then we assign the H to the height. So next is shadowing variables. So the meaning of a shadowing variable is that I may have a variable that I declare in a superclass. And all I did, I declare it again in a subclass to use it for some other reasons. So we say that suppose that a class, a subclass, suppose that the class subclass is derived from the class superclass. And superclass has a variable named temp. So we have a class, let's say employee, and a class person. Employee is derived from a person or inherit from a person. Now, if both of them, you can declare a variable named temp in the class subclass. We have this variable temp already in the superclass, and we are using it for something superclass. We can also declare the same variable name again, the same variable in a subclass. So in this case, the variable temp of subclass is called a shadowing variable. So when a variable is declared in a superclass, and again, we declare it again in a subclass, then it's called shadowing variable. So the concept of shadowing variable, again, is similar to the concept of overriding a method. So we know overriding a method means we have a method, the name and parameter is the same as the superclass. We can use the same method, the name and the parameter the same in a subclass, but it's going to perform a different work. And here we say, because a variable named temp is already a variable in the subclass, there is a seldom, if ever, any reason to override it. And it's a very poor programming practice to override a variable in a subclass. We normally try not to do it. So anyone reading a code with a shadow variable will have two different declarations of a variable seeming to apply to the shadow variable of the subclass. And this will cause a confusion and should be avoided. So again, the concept of method overriding and shadowing variable, if it's possible that you don't need them in your code to work, then avoid it. It brings or causes a confusion. So we have another example for UML class diagram named a part-time employee. So a part-time employee, we have the pay rate and hourly work. We have the constructor for part-time employee. Again, it's public. Then we have a second constructor with parameters. And we have both the two strings and also the two doubles. So you can see that here we are trying to say that the pay rate and hours work is a regular data member of the part-time employee. Part-time employee is a subclass. because we can see the string here is the last name and first name. So that's what we're going to get from the base class, which in this case is called a person. So we also have a method to set the name, set the name, rate, hours, and also get pay rate and get hours work and calculate the pay. Next, we have what we call the protected members of a class. As we mentioned earlier, now, if we have a private member in a superclass, then it always will be a private member in the superclass. Other classes can never directly access the private members in a superclass. If you have a public member in the superclass, then it's a public member in the superclass, which means any other classes in the program can directly access its members. Now, we also have a protected is mostly made for inheritance and for protection. So now if I want a subclass to inherit everything from superclass and also should be able to directly access everything in a superclass, then we have to make it public. But when we make it public, other classes that is not inherit from the superclass, we can also directly access it. So this is where the protected come in. So a protected members, the subclass can only inherit them if they have a inheritance relationship. So if I have a data member is public, every classes can access it. If it's protected, only the classes that inherit from that base class can access it. That's the whole concept here. So here we say the accessibility of a protected member of a class falls between the public and private. So protected is kind of between the two. We also have a protected access versus package access. And here, typically, a member of a class is declared with the modifier public or private or protected. This is to give appropriate access to that member. We know what public means, how we can access it, almost everybody. Private means directly no. Protected means only if we inherit, you can directly access it. Public means we can directly, anybody can directly access it. So here we can also declare member without any of these modifiers. If a class member is declared without any of the modifiers, public, private, or protected, then Java system gives to that member the default package access. That is, that member can be directly accessed in any class contained in the package. And also there's a subtle difference between the package access and also protected access of a member. Also, if a member of a class has a package access, then that member can be directly accessed in any class contained in that package, but not in any class that is not contained in that package, even if the subclass is derived from the class containing that member, and also the subclass is not contained in that package. Here we say another one, if a member of a class is protected, that member can be directly accessed in any subclass if the subclass is contained in a different package, even if it's a different package. Java also comes with a special higher ranking class known as object. Object is always to be the superclass. So directly or indirectly, object becomes the superclass of every class in Java. Again, this comes with our Java compiler, the concept. So a public member of a class object can be overriding, invoked by the object of any class type. So here we have an example of a class named clock. Clock can extend to objects, it's fine. Then we can declare the instant variable as given and definition of instant method. So this will be the conclusion of our inheritance lectures. Again, here we learned the concept of inheritance, which, as we said, is one of the main features of object-oriented programming. We went through the definition, and also we saw the implementation and the syntax also. So again, wish everybody the best, and thank you.